Well, hi, good morning. Thank you so much for joining me in my shop. Today is May 22nd, and it's a beautiful blue sky, sunny day outside. But I just spent a bit of time before coming in here battening all my hatches and getting ready for big thunderstorms that are coming. Same storms that have just gone through the United States and done a fair bit of damage. And there's tornado watches here where I live and throughout Ontario, which is a little bit unusual, but it does happen. I think I'm gonna guess. I heard this number the other day and now I've forgotten it, but I think it was 100. I don't know what the number was. The number of tornadoes that come into Canada is quite large. I was going to say 150, but I think it's 1,500, but I'm not sure. Can't remember, but nobody tops the United States for tornadoes, that's for sure. Look at this radio. You have been looking at it. Look at this. This has just got a fantastic look to it. So this is also quite an unusual radio. I don't know how many of these would be in North America here. This is a Tesla radio. Now it's not made by the modern American Tesla. This was made in Europe. It's the 308U Talisman radio. Let me get a little closer here. On the back here we've got well, starting here it says 30-100. Oh, I thought it said percent, but I think that's cycles per second. So wow, that's a very odd thing to see on the back of a radio in North America. Usually we see 25, 50, or 60, but never 30 to 100. And over here is the antenna connection. They actually have a little diagram showing the antenna, how it should be arranged. And a ground connection here showing a wire going to a water pipe. And here's the tubes, and here's where things start getting a little difficult. Here it says Tesla, the symbol there. Would look like a, that looks like a response curve on there. And right at the top is a star at the top of the, I think that's what it is. Tesla. Cool, very cool. Here's the tubes though. UCH21, UCH21, UBL21, UY1N. So those numbers are so odd, I'm not even familiar with that kind of tube numbering. It's just four tubes. Four tubes. And we see Talisman, made in Czechoslovakia. That's right. This radio was made when the USSR was around. So it says Czechoslovakia. Was that not part of the USSR at that time? So the back's in fairly good shape. It's pressed in. It's somehow got a warp in it. This way. A little cracked up in here for some reason. And the screws are the same. A little cord slot here. Let's look at the cord. Things are getting a little more. Oh, look at this. I'm acting like I'm just seeing it for the first time, but of course I know this is the plug that's on the end of this. So, you know, correct me if I'm wrong, that's a European style plug looking for 220 volts. Not a North American plug. It's just the cloth here on the cloth covering that's wrecked up. So can't plug this into any outlet I have. Or can I? Just maybe I can plug it in. Maybe I've got something here that'll do it. But in fact, this conversion kit for European voltages is actually to switch the European voltage to North American voltage. So this isn't going to help. This is the opposite of what I need. Oh, that's disappointing, but maybe I've got something here that for the first time ever might become useful to me. Check it out. I happen to have a transformer that you could plug this radio in, I'm pretty sure. Of course, this transformer is not plugged in yet. Well, the body of the plug here is wide enough that it can't get through here. What is the story on that? Mind you, the pin separation is exactly correct. Well, what? Wow. I thought I was really golden there. Now. Hey, what's in that other box? Maybe there's a combination thing that can be done here. Adapters. Great Britain, Europe and the Middle East. Is there a wild chance? I've never looked in this box. This was oh. Okay. Oh, diggity dog, look at that. Oh man! Oh, I don't want that in there. That's not what I want in there. Wrong thing. Let's try that again. Oh, yes sirree. So I can power this radio up. I'll put this in here. Maybe not. Do I dare do that? So okay, I have the possibility. Why would I bother trying to power this radio up? Yeah, you know, it's well, what would happen if I powered it up? Something bad happened. Without this transformer, no one else is going to power it up, or something similar. Well, I think it might be real interesting to look inside this radio and see what a Tesla communist radio looks like. I think this was done during the communist era. Excuse me. I think these knobs are the originals. So we'll take it out, we can take a look at it. What's it holding on to? So another screw. Oh, the back of it is split here. So I don't know anything about the history of the company called Tesla that built this radio. Tesla himself was born in Europe. Czechoslovakia, maybe? I don't know. I think his primary education was in Europe. This screw doesn't press on the knob; it actually goes right into the knob as a whole that's threaded. And did Tesla have anything? No. Anything to do with this company? Gee, I don't know. To be honest with you, he died in the late 40s or early 50s, I think. Quite a controversial figure. Certainly seems to be responsible for a lot of things, but may ultimately have been given a little too much credit for a few things. I don't know for sure. This is the band change. There's 3 bands in this radio. Careful, don't scratch it now. So obtaining a schematic for this? I don't know. There are a lot of these floating around still. It's got a nice look. Radios with a nice look tend to live on. Okay. Something rattling around in there. Looks like the only thing holding it in are these screws here. So I'm using my Runbacken Junior Testoscope from Manchester, England. When I was working full-time, I received this in the mail, sent to me by the company that makes them, I guess trying to drum up some business in Canada. Why I ended up with one, I have no idea. Right, you know, this, what are you going to test with this? In a power company. Neon lights were used a lot in the power company to indicate high voltage, and so there was a nickname. They were called Martindales. I guess Mr. Martindale invented it or something. And so you have the high voltage cable coming up in a cabinet and terminating, and the terminations are spread apart. Of course, the three phases are spread apart, and at the top of each one is a little neon. Actually, it's fairly large neon light, just sticking out from it. It's not even hooked up to anything except one side of the neon light. It's a cartridge neon light. One side's hooked up to the conductor. The other side's just sitting out in space. The cable's energized. There's a little window you look through, and you can see the martingales, and you can see that they're lit up, and you know the cable's energized. And that's sort of a, you know, you're not going over to a panel and looking at a meter. You're looking right in at the cable terminations, and the light is on because the electric field is there. I mean, it's a really, really certain way of doing it. Going over to a panel meter and looking at a light, oh, the light might be burned out. Whoa, 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 whoa. Oh, more screws. Good. Did you see how I figured that out? That was pretty impressive. Got a screw here. This looks like a voltage changing thing. It might be easy to change the voltage on this radio. Don't see a transformer in there. These tubes look really bizarre. These are bizarre looking tubes to me. Yeah, this coil is shot. I think that's the end of it right there. So this looks like something. Wow, you got to get a close-up on that. Let's get the radio right out and take a look at it, but I have the feeling we're in big trouble already here with this radio. This looks like something that would dissipate a large amount of heat, and the idea is to blow away some power, and that's why it's located at the back corner of the radio here, where it can get really hot. But it looks like it got too hot. Now, is that enough to pull this out? Let's push on the end. No, it isn't. No, because there's a screw, of course. Oh man. So, okay, who's got to come out? Wow. There's a screw up there. I'm pretty interested in seeing, you know, what this looks like, because usually I'm seeing North American radios, of course, and Canadian-built radio, American-built radio. There's not enough difference there to write home about. Now there's more screws up in there. What are they holding? A very strange looking speaker. Okay, did I get enough already? Let's see if I can. Yeah, that is enough. Just the one clip. Okay, come on out. This is probably the first time this radio's been out of its cabinet in a long, long time. Freedom. Okay, take a look at the cabinet. There's a washer wandering around in there. So this clip was not engaged, or ooh, this whole piece is coming out here. Okay, I'm looking for cracks or anything that I should really be worried about. Up here is a manufacturer's stamp, VG. Very good. and there's no cracks or anything in here. It all looks great. Okay, we'll set this aside where I can't do terrific damage to it, and here it is. Wow. Let's see if I can get the camera a little bit closer here. Well, nicely written here. 308U Tesla 120 220 volt, and this is the adjuster. So I may not even need the big transformer here. I may just have to turn this the right way. Now there was a window in the back, and I didn't point this out, but because I saw the plug as soon as I saw the radio, I looked. There's a volt window here. You look through to see what the volt setting is, and it is 220 on here, and this is probably 120 down here. So probably you just pull this out, turn it around, stick it back in, change the plug on the end here, and voila, we're in business. Probably. And what kind of business are we in? These are, like, this is a really weird looking tube. These got to be really rare. Metal base here. At least here in North America, these would be extremely rare. A lot of radios built in Europe have tubes that have their counterparts here in North America. They might look slightly different, but their operation is exactly the same. So a lot of European radios, you can swap the tubes with North American tubes. So a lot of things are catching my eye. So, you know, here's this blown coil here, or at least loose. You have to think if it went like this, it was no doubt all. Oh, there's a whole bunch up in here still. Oh my gosh, it's so thin. This might be what they were doing to enable 220. What do you think of that? They dropped 120 volts on this little heater here. It's really a 120 volt radio. It would be easier to build a radio to run on 120 volts and then adapt it somehow to 220 than to go the other way. I think. So I see there's a string on the front. I haven't tuned this radio at all. And some interesting looking coils here mounted on a board. And two weird looking things sticking out here. What are these? There's something here. It looks like it might be a capacitor. A lot of light wires right in here that could break easy. Danger, danger. Got two twin light bulbs. Got a sock over top of the speaker. Speaker is a permanent magnet type. The output transformer is sitting up on top here. We have the two IF transformers. The tuning is in through here, not through the top or the bottom. We have a filter capacitor sitting here. The tuning capacitor down here, both sides are the same size, same dimension. Just making all the observations I can. And screw here. Another washer. Not sure what to make of that. Okay, if we tune the radio, oh yeah, pointer goes. Well, isn't this kind of odd? The pointer, instead of being dead center in the glass, is off to one side. And this leg of the pointer is shorter than this leg, which is longer. Which gives you more area to write stuff in. Maybe that's what they did there. Because there's a lot written in here. We'll take a close look at it in a minute. But it turns all the way. No, it doesn't. String tuning. Okay, swallow deep and look inside. Which way can I tip this? Since I don't see any transformer, this is sticking out the end here. If I put it up on this end, we're banging into this thing, which I don't know what it is. These parts are sticking out. If I put it on its face, what? I flip it right upside down. It'd be sitting on these and these. That's not so bad. That's not so bad. Let's do that. There we go. Oh. Okay, sleeves. Ooh-wee. I do say. So at a glance, there's a lot of parts in here that look a little different. Here's one you can see the word Tesla written on it, right here. This is probably a capacitor, 300 picofarad, it says right on it. Tesla here. So the parts are being manufactured by the Tesla company too. Well, let's see, these are all molded capacitors now. That makes them a little better. This one, I guess it's dirt there, is it? Looks like it's melted into the thing. It's just dirt built up. Whatever this thing is. What is this? Couldn't tell you. Lots of light, very thin wires down in here. Like real thin stuff. More of these things. There's thing. Oh, don't fiddle with them. These are all resistors here. There's a lot of airborne connections. A style that's not normally done by a manufacturer, but done here, but done nicely. Power cord coming in. Looks like a double pole, double throw on off switch. The power coming out of here. Heading is for this thing. Well, I think I'm going to stop at this point and drink some coffee, and then I'm going to take a look for a schematic, if by some chance I can find one, and then we'll just carry on slowly and carefully. If you can hear a bit of a roar in the background, that's my air conditioning running in the house here. Yeah, time for air conditioning already. Okay, so I just searched for the Tesla 308U Talisman. Here's what I got. We'll look at this in a moment. So there is a schematic. Here's some pictures. Other people have done videos on this radio. One of them's over half an hour long. So, yeah, it doesn't look like it's in English. Some more information here. Antiqueradio.org has some information. Radios Past. I've never seen this website before. You know, it's a big internet out there. So I have opened this. Let's take a look. Here it is. So we'll just zoom down quickly, take a look at what's here. Pictures, words, some stuff at the bottom there. Banks Canada. Tesla Talisman 308U. When I started collecting radios in the late 90s, it seemed like I wanted to buy almost any radio I spotted at a reasonable price. In a short while, I decided to concentrate mostly on Bakelite, Catalin, and other types of plastic table radios. Plastic was the new medium in the 30s and 40s, and designers came up with such clever modern designs. One radio that really caught my eye was a maroon Bakelite radio from Czechoslovakia. Bakelite? I think this is Bakelite. I'd seen a photo of it in a tabletop book on Bakelite. Okay, Must be Bakelite then. And the streamlined style really appeals to me. Yeah, it's really cool looking. An added attraction might have been that my grandparents on my mother's side were from Czechoslovakia. I never saw a Tesla in anyone's collection at the time, and certainly never came across one at an antique store or auction. Finally, I spotted one on eBay, but the auction had already ended. I took a chance and sent an email to the seller who was in Europe. He had another one. He sold it to me for the same price. $200 plus shipping. That sounds about the right price to me for this radio. Maybe a little higher, actually. Radio books have had trouble nailing down some of the details of the Tesla. Above are two book listings. The top one is from a 2014 book, Deco Radio by Peter Sheridan. It shows the Tesla as being from 1946. Bottom photo is from 1997 book called Bakelite Style, which was edited by Tessa Clark. It says the Tesla was designed in the 30s, produced in the 40s, which is what I believe because of it. Apparently both books are wrong. The best information I could find online is that the Tesla Talisman was designed in the late 40s and produced from 53 to 58. That sounds about right to me. The look of the radio and the light and that. Look, it's got the plug here. It's got an adapter on it so it can go into a North American outlet. Another interesting comment was that was in the Bakelite storybook was that Tesla was highly desirable in the Iron Curtain days, meaning that Teslas are less desirable now now that they're more available. Huh? What? Let me read that again. It was highly desirable in the Iron Curtain days, meaning that Teslas are less desirable now that they're more available. Well, maybe what he's trying to say here is that these things were not around the world. They were kind of trapped behind the Iron Curtain, and so they weren't popular at all outside of, the USSR. To me, the radio is as desirable as it always was. It's just cheaper for collectors. Cheaper. Tesla's tastes vary, but I think it's one of the coolest radio designs ever. Well, there's many, many, many radios out there. The Tesla is also available in brown, Bakelite, and black Bakelite. If you see one painted, it's not original. The Tesla can be easily switched between European and American voltages, and the plug works with an inexpensive adapter. Wow, okay, that's encouraging because that's what I'm about to do. One unusual and cool feature is the dial. It has the major cities of Europe printed right on the dial glass along with the radio frequencies. Well, we'll take a look at that one. When I reduced my collection, the Tesla Talisman was the one I couldn't part with. It stayed in the collection. And you can see the knobs are the same as the knobs that are here. As I was commenting that these didn't look like they were original, but I guess they are. Okay, that's interesting. Now we're going to take a look at the schematic. Well, we'll take a look at this entry here. 4 tubes. Is it going to say anything unusual in here? Probably not. Tesla, sorry about the way my pointer's doing that. Tesla Praha, Bratislava. Sorry for my pronunciation or lack of it. Oh, German here. And look at how many of these things are in people's collections. These are people who have this radio and have sent a photo in to this website. Holy smokes. There's a lot of them floating around. And you know why? It's because of the look of the radio. It's the same reason this one's here. It's the look of the radio. So I am going to download some of the data information here. We have a schematic. We have another schematic. 2 schematics. We have a wiring layout. This is a very, very valuable diagram. And then we have some talk here. This is probably the alignment chart. Well, I'm going to download some of this stuff. And we'll take a look at the documentation. And then I'll get bold and we'll try operating the radio, I think. Okay, just returned from mowing my lawn because the rain is coming and I won't be able to mow it for a few days, I think. Whew, it is hot outside. It's 27 degrees with high humidity. Just a storm type material, but blue sky. Hot sun. Have I ever sweated up here? Okay. Never mind that. Let's look at this. So I have this schematic. Fairly simple radio here. One IF, another IF. What we're really interested in, complicated coil arrangement here. We're interested in the power supply. And what are they doing here? Oh my gosh, am I going to be able to figure this out? And most importantly, where is the how can I put it? The big wire resistor that looks like it's fried up. It should be in here somewhere, I would think. Or is it in series with these heaters? Where are they showing the heaters? So somewhere there's got to be the other side of this. There's no transformer in here. So how do they ever get the voltages down on these tubes? And what are the voltages for these tubes? I don't even know. Whoops. 21, 21, 21. What's the 21? Often the heater here is a different kind of heater, but in this case this tube has a cathode, so probably same voltage. They don't show them in series. There's another schematic. Okay, let's keep going. Okay, we looked at this one enough. Here's the wiring diagram. And of course I'm not showing anything up on top, and that's where that wire wound resistor thing is. Wow, pretty busy in here. Nicely done diagram though. Should be able to sort things out if I need to. It's information, but look, it's written in what language would that be? Is Czechoslovak a language? Czechoslovak. So you can pick little bits and pieces out of here. 32 watts, 120 volts, 45 watts, 220 volts. And that's about all I can understand out of that. And this is the chart for aligning the radio. I could probably sort my way through that. But there's special messages in here for someone like me. I'm not going to pick them up, I don't think. 12 kilohertz. What would that be? That would be the, I don't know what that is. Do we see anything like 455 in here? Here we are. So this looks like different bands. And these are the different bands. Oh, here we are. 452. So this will be the IF frequency that they've designed the radio around. Unusual. 452. Okay. Onward. Now here's a better looking schematic. Maybe we can sort things out here. Where is the weird resistor? Let me just make this a little bigger. 20 ohms, so it could be these. So they're coding something in these two lines, one line. They're coding something here. Wattage. They're coding the wattage with these lines. So the wattage of that thing would have to be like 30, 40 watts. Nothing like that listed here. So where's the 120 240 switch? How do you do that? There's no transformer. So I would think you'd be bringing in and taking out that heater element. Well, here's the heater string here, right across the line, and there's some kind of switching arrangement here. What's this? And another resistor, 20 ohms. That looks like 700. It might be 200, but I think it's 700. VII, there is no VII in here. So, yeah, this one's got, looks like 3 lines, 3 watts. Well, maybe we just count this. This is 7 watts by Roman numerals. 7 watts. Most tubes are 3 watts, 2 watts, 3 watts. Maybe these are a little different. I have to learn about the tubes that are in here. I have to find some information out about, especially the heater values. Because what are we going to do? We plug it into 220 and drop not only 120 here to get down to 120, but drop it right down to almost nothing on a 7 watt resistor. I don't think that's happening. So now, what if you're on 120 volts? What is this? Z1, Z2. Well, what's that supposed to be? Is this the little device you pull out the back and rotate? This would be the device you pull out the back and rotate. Does it say how it's shown? Maybe it does, but it won't be in English. Is it shown for 220 or is it shown for 120? They just put a thing there. What's all this? 220, 120. What is all this stuff? All this stuff. Does it sit on top of here? Okay, not quite sure what they're showing here. Oh, they're showing the 220 arrangement like this and the 120 arrangement like that. And what is being arranged? Is it the plug you've pulled out and turned around? Oh, I'm so full of questions. So many questions. Okay, let's leave that aside for a minute and take a look here. Now, what is that? Capacitor. Okay. No doubt there. Come on, mouse, keep working. So this looks pretty typical of a power supply. A 2000 ohm resistor here. And, you know, from there, the radio's going to be kind of like any other radio, but not so much. What's all this? This must be the oscillator coils here, probably. Yes. Hooked up to this wild switch here. Good grief. And come into this very busy tube here. So input on the grid here, output into here. What's this triode doing here? Come over here, we have another busy tube with 2 diodes for detecting. Yeah, okay, I can see that. And then we have, instead of a usual triode, we've got a, what do you call this? This is a pentode, 1, 2, 3. Pentode. And has a screen. Well, this is the output tube. So this is functioning as the output tube and detector at the same time. Oh, and then this is what? This appears to be hooked up to the grid. Oh, I didn't look at this close enough. This is coming to a diode. Yeah, this grid is coming from here. This grid is coming, let me guess, from the volume control. Here it is there. So, you know, although it's got its own machinations, I guess all these radios are generally the same. Even this one, made in the USSR. I think this was the USSR. Maybe people in Czechoslovakia didn't like to think of themselves as part of the USSR. I have no idea. Here we see a ground wire grounding the core of the speaker, probably the frame too. Okay, back to the power supply issue. There's nothing surprising in the rest of the radio. Just this clearly, I got to understand what this is. But it would look like I just have to pull a thing out of the back of the radio, turn around, stick it back in. We're in business. Let's see if we can find this shape somewhere in the radio. Well, most likely this thing here. Okay, let's pull this out. There's no polarization in this as far as I can see. So I had the 220 up like this. And we would want to put it in like this, the 120. Well, who am I to doubt them? There we are. Ready to go. You think so? 120 means they made this possible to be operated in North America. Because who else is using 120 volts? Anybody else? Maybe a few places here and there, but mostly North America, I think. So if we were to power this up now, what bad things could happen? Well, nothing really. Everything. Nothing and everything. So we need to convert this to a typical North American plug. Let's see if I have such a converter. Ooh. Whoa! Wow, what's that? It's for plugging in your stove. Holy smokes. I do not have a, yes I do, I had this black one. No, it's the other way around. They're all the other way around. You can't really plug it in. What's this thing? 1600 watt converter. I don't have an actual plug. Okay, but I got a cheater cord here. Hand me the cheater cord, please. I do not recommend using this kind of thing. Here, let me just give you a little better view here. Don't do what I'm doing. Okay, I'm going to operate this radio, but I'm going to control the input voltage a lot. And start it out really low. And I'm also... So we're just going on the assumption that all you got to do is turn that thing, this busted piece here, not in the circuit anymore. That's my guess. It's just a guess. Could be completely wrong about that. I'm going to feed the power through two light bulbs here in what's called a dim bulb system or arrangement or circuit. So I'm going to force the power through those lights. At the same time it's coming from here. I have control here. I can turn it way down. Okay, we need to practice here. That's the on off. First we'll turn it off and make sure off goes off. And then this is the tuning and this is the band, and we're going to go all the way. All the way. Oh, not quite yet. Very soon. All the way there. We'll assume that's a broadcast band. What I would expect when we go to operate this is it hums. That's my expectation. Here we go. Okay, starting out with very low power. Switches off. Nothing should happen. So it's 77 volts on the switch. Nothing happened. Good. We turn it on. And we get a little nervous. Turn it up a little bit. So what should happen here is when I turn it on, the heaters are cold. current rushes in, these lights go bright. In fact, I'm going to reduce this to one light. Really restrict it. This light will go bright. The heaters heat up. They heat up slowly when the current's restricted like this, but as they heat up, the resistance goes up, current goes down, light goes down. Once these things heat up their cathodes, cathodes begin emitting, current starts flowing through the tubes, and the light gets brighter again. And this all happens in about 10-20 seconds, something like that. Are you ready? So it should go whoosh, down for a little while and then come up, and when it comes up we should start hearing sound out of the speaker. We may just hear a hum right away though. So here we go. Okay, light is on. Barely. You can't even see it. It's drawing almost no current. Drawing almost no current. A little surprising. No lights. I don't think this is working out. I think we should see more happening here. So this has just gone to nothing. Well, let's give it a little more juice. Juice it up a bit here. So these hard to look down through the tops of these tubes. You look down through this one. Okay. Let me darken the room here. I can see any tubes are lighting up. Here we go. Darkness. There ain't no light in any tube. Six watts. 80 volts. Let's go higher. So the light bulb element is just barely visible there. So not much voltage dropping there at all. Not much current being drawn by the radio. .92 volts. So I don't want to do too much of this thing. I don't want to be the guy who degrades it by fooling around with it, which I have a good potential of doing that right now. I am watching this thing. Nothing's happening here. Let's check again here. I don't see any light in any tube. You know what? There was light here. Yeah, I'm pointing at it. You can't see it. Darkness. Where's the switch? Can't find it. There's the light switch. This light came on ever so slightly. Where are they in the circuit? Let's take a look at how the lights are done in the circuit here. Okay, lights. Maybe that's what these are. These could be lights. Z1, Z2. They would be showing kind of weird if this is light 1, light 2 here. So the thunderstorm warnings are starting to arrive. Our government issues that, just like I think most countries, it issues warnings, and I just got one. Thunderstorms are coming. Well, I don't, unless these are the two lights, what else could it be? Very odd. They're in series. It'd be very kind of a dangerous way of doing this, but one of the problems with a radio like this is finding the voltage to operate pilot lights. That's a tricky thing, and often it's done with the heater on the rectifier tube, but not in this radio. So maybe that's what those are. Let's look at the other schematic. So the 6.3 volts, 0.3 amps. So they're describing a light bulb here. In fact, there's the number. It's a 57. I think Am I right? But at 57, did they number these parts? 25. That's a value. That's a value. That's probably a value. So this is probably a value. And the value is probably the number for these lights. Number 57, that doesn't really ring a bell. So that's what's going on with the light. So the lights would show, if the light is lighting up a bit, it's got some current going through it. What is all of this? And here we have that pretty sure the thing I rotated. Once again, they're not showing where the heaters are going. I'm not finding that. Wow, they really left that out. Like, how have they done? How have they done this? They would appear to be in parallel because they're all going to the same spot and running with the same voltage. Maybe these tubes have a ridiculously high voltage. Maybe it's written right over here. I don't know what that is. I gotta find out what kind of filament voltage these tubes have. Let's do that next. And it might be a good idea for me to turn this off instead of leaving it running like this. So 93 volts, 8 watts. 8 watts. Huh, some heat in this one. Oh, I can see the glow. Yeah, I think these are all... This one's cold. This is either the rectifier or the output tube here. Oh, there might be a bit of heat there. Let's give it a little more. 93. Let's show them who's boss here. We'll pump it up to, it's 102 now. Turn this up. I'll change the bands and see if there's a crackle. Not crackle. Tuning it won't do anything. She's dead, Jim. We got 103 volts on it. I gotta be careful with that thing. And nada. Okay, I'm gonna cut the power to it. And we were gonna take a look at something in the schematic. What was I gonna look at? I forgot now. Oh. The Radio Museum has some information about one of the tubes, the only one I've checked so far, UCH21. And interestingly enough, if we come down here, we see voltage filament 20 volts. So that's how they're doing it. There you are, 20 volts right there. If there's 4 tubes at 20 volts each, that's only 80 volts, so you still got to knock some off somewhere. Or the other tubes have different voltage drops, but they're all going to have the same current. They must be in series. But they didn't show that on the schematic, which is very odd. That's an important thing. The order of the tubes, and sometimes there can be coils and capacitors involved with the heaters. This tube has a cathode, so that's not a concern. Okay, that's how they must be doing it then. Well, I think this radio is just a little bit beyond my comfort zone to work on it. The lack of English in the information, the fact that it didn't really come to life, goodness knows what's wrong. The tubes are really weird. Where would you get one? I wouldn't know. I just think the most I can do is make this worse and worse and worse. So it's a good looker. I think that's the value in this particular radio. It's just got a beautiful look. Maybe I'm not going to play it, but it still is a kind of a special looking radio. So not like this, but maybe when it's back in its cabinet. Okay, there we are, and the red color comes out a little brighter on the camera than it is really. It looks kind of brownish here, but it looks a little reddish, at least on my screen. It looks reddish. Beautiful looking radio. these knobs, you see how this one is split? That's from driving the locking screw too far. It can just go right through and it'll push on the other side and split the knob. That's what's happened to these knobs. Not this one though, this one's okay. So not to tighten the screw all the way. I left them quite loose actually. So let's take a look at this dial face, because that's kind of a cool thing. And I think it'd be fun to look at it. So let's do that. Come on, mouse, don't quit on me now. Yeah, I've got to get a better mouse for sure. Okay, over here we go. Give it a moment to focus. You're going to focus, aren't you? Maybe not. Okay, I'm going to have to force the focus on this camera. Oh, there it goes. Good, good, good enough. Okay, let's start. Well, look right in the middle, this red area. Delhi, London, Sackville, New York, Motala, Moscow, Schenectady. Now that kind of mixing the world up there. London, Shepperton, Monte Carlo, Wien, London, Praha. I don't know where that is. Moscow. Those are. Now maybe those cities don't even have those names anymore. Well, that's in the middle. And then coming around the outside here, Frankfurt, Zagreb, Bratislava, Wroclaw, Leipzig, Graz, Dublin. Some of these names I've never heard in my life. Berlin, obviously. Brno is missing a vowel there. London, Bucharest, something's missing. Roma, Sofia, Stockholm. Where's Toronto? Where's Montreal? Not going to make it. Hilversum, Charkov, Praha. Now, really, were those stations really located at those frequencies that you could mark it on the radio like this and tune and find those cities? I guess it must have been the case, or they wouldn't have done this, would they? And it's on all kinds of radios have got this. Broman, Riga, Lyon, Helsinki, Budapest. And we come over here. There's an indication of how the band selector works down in the corner there. And we come up Minsk, CSR 1102.9. What is that? D-sender. I haven't heard of any of these places. Whatever. Warszawa. Ooh. Oslo. Droitwich. Motala. I mean, if you're from Europe and you're watching this video, you're probably laughing your head off at me here. Ankara. Ankara, I think is a better pronunciation. Moscow again. Strasbourg. Brasov. Well, interesting. Interesting stuff. When my father left me an extensive stamp collection, and is full of stamps from countries and places that don't exist and haven't existed for, you know, maybe 75 years. It's kind of neat to look through the old stamps. A little like doing this. Anyway, there we are. Beautiful looking radio. Really nice on the shelf. No doubt about it. Definitely a collector's item. Wonderful. If you're collecting radios, this is a wonderful one because look at it. It's just fantastic. Okay. Well, thanks a lot for watching. And it might be a few days before I post the next video. See ya.